So the main things in trigonometry, sine, cos, and tan. How will you use the sine and cosine and tangent? Pretty much to find unknown angles, to find unknown sides. That's what we do. And we did that example to find the height of the building, right? Just an example. That gives you an idea that you can just use those triangles, and if you know an angle, you can find the sides if you know one more side, and that is what we did. Going back to that problem that we're working on. What was the problem that you're working on? 10 miles and then 20 miles, right? So this is the resultant, which was 22.36 miles. We found the resultant's magnitude. Now to get the direction, we have to go and fetch this angle. Now to get this angle, look for a connection between given quantities and this angle. This is the opposite side for this. This is the adjacent side for this angle. So a trigonometric ratio connecting opposite side and adjacent side is tangent. So tangent of the angle is 20 over 10. And so angle is tangent inverse, which is second function tan of this ratio. And that will be what angle? 63.4 degrees. And how we need to express this angle is by
East of north.
You can say east of north. That's right. That's north. That's east. So say east of north. You know, some of you are confused about this east of north. Is it from there, from the east to the north, or north to the east? You know, that sort of confusion. East of north. I will say, instead of looking at this word as off, read it as from. You may understand it better then. 63.4 degrees east from the north. So you start from the north and go east. Okay? You can also express the angle here and call it north of east. So what will be the rest of the angle? So if this is the angle that you're referring to, how much is that? 26.6 degrees. That will be north of east. So 26.6 degrees north of east. All right, any questions about how to find the resultant in the angle? Good? No problems at all? So if you're given two vectors that are right angles to each other, then you can find the resultant. When are you going to have issues then? When it is not right angles. When it is not a right angle, then you may have some problems there. So if it is not at right angles, like this, let's say for example the 10 miles you went northeast. The 10 miles you went northeast. And then the 20 miles you went east. So the 10 miles you went northeast and the 20 miles you went east. What is your resultant? So the resultant displacement in this case is here. That's the resultant. Is it the same thing as 22.36 now? No. It's different. Now to find the resultant here, we cannot use Pythagorean theorem. So what we do is we use again a mathematical method of determining it. And how to determine that is by using a rule called cosine rule. And what is the cosine rule supposed to help you with? A cosine rule helps to find the third side of a triangle when two sides and the angle contained I don't know. When the two sides and the angle contained are known, then you can discover the third side of a triangle. This has nothing to do with vectors, okay? This is a mathematical tool that you can always use for anything. I mean, if you're stuck in geometry, you don't know how to find the third side, you can use this rule. So what is this rule about? If you have a triangle, if you have a triangle, any triangle, if you have a triangle, if you know two sides of the triangle, let's say you know this side and you know this side, and the angle contained. Do you understand the term contained? If you know two sides and the angle contained means the angle that is trapped between the two sides, then you can find the third side by using this expression. C is equal to square root of a square plus b square minus 2ab cosine theta. That will help you to find the third side. So it applies to any triangle, not necessarily vectors. Any triangle, if you know two sides and the angle contained by the two sides, the third side you can mathematically evaluate. For any triangle, not necessarily right angle triangles, any triangle. So the third side is a square plus b square minus 2ab cosine theta, all root. So let's apply that here. So we know this side, right, 10 miles, and we know this side, which is 20 miles. Do you know the angle here? How much is that angle? 135. How did you get that?
45 degrees plus 90.
See, you know, northeast is 45-degree angle. So if you just imagine, if you imagine the north and the south line, that's 45, and that is 90. So 45 plus 90 is 1. So it's already there. Okay? The only thing is you have to visualize it and understand it. All right, so that is 132. We have this, and we have this. You need to find R. So what is R? Square root of 10 squared plus 20 squared minus 2 times 10 times 20 times cosine 135. What do you get? Everyone work on the calculator and tell me the answer. That will give us the resultant. Everyone should work on the calculator. Got it? How much?
28 miles.
28 something? So 28 point?
27.9, but I just rounded it.
Okay, let's keep it as it is. 27.9 miles. So
27.97.
Oh, okay.
9.8.
28 miles. That is a resultant. But that's not the end of the story. We need to find the direction. Because this only tells you the magnitude. So this displacement here is 28 miles, that's all. But you need the angle. So for the angle, we need to discover this angle. One of the angles. Let's discover this. If you can discover this, then everything's over. So how do you geometrically discover that angle? Huh?
There's another equation.
There is another, what is that called?
It's basically, you just need to do some algebra to that. Like, it's cosine an angle equals to a squared plus b squared minus c squared over 2 kind of is that.
Oh, so you're basically going to use these two sides
Oh yeah.
and then solve for this,
three sides. Yeah.
and then work backwards to find the angle. But there's other way to do it. And the other one is known as the sine rule. This is cosine rule. The other one is called the sine rule. Let me draw and help you to get the sine rule part of it. So what's the sine rule? The sine rule helps you to discover unknown angles and unknown sides. Okay? It helps you to discover unknown angles and unknown sides. So if you have a triangle like that, if this is A, this is B, this is C, and this is angle A, and this is angle B, and that is angle C. Can you see how I wrote it down? This is angle A, and the side that is exactly opposite of that is small a. And this is angle B, this is B. This is angle C, that is C. If this is what it is, then A over sine A is equal to B over sine B is equal to C over sine C. This is true for any triangle. Any triangle. This side divided by sine of this angle is the same thing as this side, B, divided by sine of this angle. It's the same thing as this side divided by sine of this angle. Now you can see that there are two equalities. You don't have to use both the equalities. You either use this to solve for one of them, or you use this to solve for one of them, or you use this equal to this to solve for one of them. So whatever is required. So you just need only two sets of ratios to compare. This is called the sine rule. And how do I apply that here? Let's go there. Find out if you have a side and an angle corresponding to it. We have a side here, but do you know that angle? So I can't use that. We have this side, and this is the angle that I need. Do you know this side? 28. We have it as 28. And you know the angle? So that's what we do. So side 28 divided by sine of 135 is equal to 20 divided by the sine of the angle. You see how I set it up? A known side divided by the known angle, sine of the known angle. Another known side, and angle is not known. Now we need to solve for this theta. So what do you do from here? You cross multiply. When you cross multiply, you get 28 sine theta is equal to 20 sine 135. So sine theta is equal to 20 sine 135 divided by 28. And then you get something, and then what is the angle theta? Can you work backwards and find out the theta? Second function, yeah.
30.3
That looks right. 30 point? 30.3 degrees. That looks right here. See, when you get an angle and when you're comparing it with this, it looks fine. 30.3 could be that angle. So that's how we find the angle. But how do I represent the direction? I can't say 30.3. You have to say which way. Now 30.3 is from here to here. So the resultant is making 30.3 with the northeast direction. We don't want to express in terms of northeast and all that. We need to either with respect to north or with respect to the east. All right. So if I draw the east-west line and the north-south line here, if you can get this angle, then you're done. What is this angle? So what is this angle? 45. And what is that angle? 30.3. So what is this angle? Subtract. Okay? This is 45. This is 45. You know this is 30.3. And so what is this angle here? 14.7 degrees. Now you can express. The answer is 28 miles at 14.7 degrees what? North of east. Any questions now on this? Cosine rule, sine rule, both applied. And we got the answer. Yes.
So technically you could do 75.3 east of north.
Oh yes. You can also say from this side. 75.3 degrees east of north. That's also the same thing. Both are ways of representing the angles. Any questions about cosine rules and sine rules? How many of you understood cosine rules and sine rules? How many of you did not understand cosine rules and sine rules? No one? Good. Yep.
I just have a question about like when we go from sine theta equals 20 sine 135. Like, what do you do to get?
And then second function, sine, and then whatever answer you got.
Okay.
You press second function, then sine, and then the answer, whatever you got here. That will get you the 30.3. Plug it in, see. First get this part. How much is this? Make sure your calculator is in the degree mode. That's most important. Do this part of it. What do you get this as?
0.505.
Point? 0.505. Now what do you do? Press second function, sine, and then put 505, 0.505. And got it? That is how you kind of work backwards from the ratio to the angles. So you should be able to go from angles to ratios and ratios to angles so easily. Get used to it. So the cosine rule and sine rule helps you to find out the result no matter what. It doesn't have to be 90 degrees. Now, if you look at this cosine rule once again, what's cosine rule? C is equal to square root of a square plus b square minus 2ab cosine theta. What happens when the angle is 90? What is cosine 90? We discussed that last class. What is cosine 90? Oh, plug it in. Cosine 90.
0.
0, which means this entire thing vanishes. When the angle is 90 degrees, this whole thing vanishes. If the whole thing vanishes, what is left? Pythagorean theorem. So Pythagorean theorem is just a special case of the cosine rule. You get it? Pythagorean theorem is just a special case of the cosine rule. The cosine rule is a general rule to find out the third side. But if you have a right angle, then it makes it easier. Okay. There are three vectors. And you'll find the resultant of this three. Like, for example, if I give you, alright, this one, and this one. How do you find the resultant of all these three? Now, the angle is again not 90 degrees here. So what do you do now? Break it up? How? Like do two at a time?
Yes.
Yeah. So what he's saying is, take these two and then use the cosine rule and get this, and use the sine rule and get this. And by discovering this, you can discover this, and therefore discover this. And then you take this answer and this one, and then work it out again using cosine rule and sine rule, and get this, which is going to be our resultant. Right? Now, what if you have 10 vectors? If you have 10 vectors, what are you going to do? You take two at a time and then keep on doing cosine rule, sine rule, and angles, and yes, you can do it, but in the end, you'll get a wrong answer. Why? Because you'll go wrong somewhere. Even if I'm doing it, I'll go wrong. Because we are human beings. We're like missing a single digit somewhere, or missing a minus sign somewhere, or angle somewhere. You don't know. When you're doing the same process 9 times, there is a chance of making a mistake. That's why I said you do all that and finally end up getting a wrong answer. So if you have too many vectors, then we don't use the mathematical method of cosine and sine rules. Then what do? Go for the method of resolving, the third method I told you. In fact, I never use the cosine rule and sine rule for any problem. It's not required. I just showed you so that there is an option. If there are 2 vectors and you want to find the resultant, you can use it, but you're not going to be compelled to use cosine rules and sine rules. Not necessary. But resolving, yes. You have to know exactly how to work with resolving. So let me explain to you what is this resolving thing. The word resolving means splitting. Splitting one vector into 2 vectors. Splitting one vector into 2 vectors. That's what it is. So if I'm going from here to here, this is my intention. This is the vector. That's the vector A. Going from here to here, in how many different ways can you make the same movement? Starting point is here, ultimate ending point is here. In how many ways can you make 2 displacements to get there? You need to make 2 displacements to get there. In how many ways can you reach there? Infinite number of ways. Infinite number of ways. Why? Because you can go from here to here and then go there. You can go from here to here and go there. You can go from here to here and go there. You can have infinite ways of doing it. But we're not interested in all those infinite ways of doing it. We are interested in only the 2 ways which are perpendicular to each other. So I go here, then I go there. Now these are called the components. These are the components of vector A. This is vector A, and those are the components of vector A. What is special about those components? They are at right angles to each other. One is completely horizontal, the other is vertical. Those are 2 ways of reach. So what is the best way for me to reach from here to there? I can go there, and then make a right angle turn and go there, right? So this is going to be our vector that is split into 2 vectors, namely this and this. Now, these components need to be called by some names. What name can we call this one as? Let me explain to you. If this is the angle that you're looking at, what side is this side for this angle? So you can call this adjacent component. What would be this component called? Now, isn't this one horizontal? So you can also call it horizontal component. That one is the vertical component. Is it lying along the x-axis? Then you can call it x component. That is y component. So how you call these components is purely up to you. It's purely up to you. But The first way I told you, adjacent component, opposite component, that's the most important thing. Because why this is going to be called adjacent component is because this angle is right here and is touching there. Because if I talk about this angle, then this will be the opposite component. Okay? Alright, so the components can be called by different names: adjacent component, opposite component, x component, y component, horizontal component, vertical component. You can call it anything. So this is the adjacent component and this is the opposite component. I prefer to call it that way because that will connect you mathematically to the right equation. So what is the connection between this side, and this angle? What connection is that? What connects the adjacent side, the hypotenuse, and the angle? Trigonometric connection. The cosine. So cosine of theta is equal to adjacent over A. So what is adjacent? Cross multiply. A cosine theta. Similarly, what's the connection between the opposite side and the hypotenuse? What's the connection between the opposite side and hypotenuse? Sine of the angle is equal to opposite side over the vector that you're trying to resolve. So if you cross multiply, we get opposite side is equal to A sine theta. So if you're looking to find the opposite side, just take the vector and take the sine of the angle. If you're trying to get the adjacent side, take that vector and take cosine. So it's an easy way of doing it instead of always going and finding out which trigonometric ratio and all those things. Not necessary. Are you looking to get the adjacent side? A cosine theta. Are you looking to find out the opposite side? A sine theta. You get it? So we have the two components. We have the two components. We have the two components. This is A cosine theta and that is A sine theta. So if I give you two components, one going this way and one going this way, can you use these two components to find this? What do you do? If I give you the two vectors and ask you to find this, yeah, you're finding the resultant, right? So resolving is simply the opposite of finding the resultant. Again, if you have a vector already here and the angle, you can split it into two vectors. If you have two vectors already, you can find the resultant. How do you find the resultant here? You use Pythagorean theorem, which is square root of that square plus this square. And if you simplify that, you get square root of a square sine square theta plus cos square theta. What is sine square theta plus cos square theta? 1. Why? Why is it 1? Yes, it is 1. Why is it 1? You see, we are getting that. Why is sine square theta plus cos square theta 1? I know it's a trigonometric identity, but why? No idea? It's very simple. If you have A, B, and C, and this is the angle, what is sine theta? What is sine theta? A over C. What is cos theta? B over C. So what is sine square theta plus cos square theta? It's A square over C square plus B square over C square, right? So common denominator, A square plus B square. What is A square plus B square? C square. So C square over C square. Okay, so y is sine square theta plus cos square theta is equal to 1. There's the proof. Okay. So did you see this one here? You have the adjacent component, you have the opposite component. We got our original vector A. Get it? You understand the idea of resolving? So what is resolving? Splitting a vector into two components. Now by splitting a vector into two components, especially in the horizontal and vertical directions, you can make things far more easier than using cosine rules and sine rules. So I'm going to show you how to do that through an example, and I'll make you do it. So here's an example. Let's say somebody makes a displacement of 10 meters east. Somebody makes a displacement of 10 meters east, then goes 20 meters at 30 degrees north of west, then goes 30 meters at 40 degrees south of east, then goes 15 meters west, then goes 8 meters north. The 5 displacements, what is the total displacement? What's the resultant of all these 5? Okay, that's what we're going to do. So the approach is this. Instead of using cosine rules and sine rules, what we do is first draw all those things: north, south, east, west. And on this picture, draw all these vectors, all starting from the origin. Draw all the vectors. And you can also label the vectors, A, B, C, D, E. So where is A on this picture? Where's A? How will I draw it? 10 meters east, right? So here it is. Where's the next one? 20 meters at 30 degrees north of west. Where is it? Where is north of west? Of course, it should be between these two. So where is the 30 degrees? North of west. North from west. So it's from here. You get it? So at 30-degree angle, 20 meters. And then this is vector B. This is vector A. The third one is 30 meters at 40 degrees south of east. Where is it? South of east. South from east. From here, 40 degrees. And then we have 15 meters west. Always draw a big diagram. The smaller the drawing, you're going to mess up things. So you look at the size of my drawing and go proportionally on your page. Okay? If you started drawing something pretty small, just make it again. No problem. Because we're going to draw something more inside it. So if you keep a small drawing, it will confuse you later on. Even this is confusing me. Look at the 10 sitting here. I don't like the 10 here. I like the 10 here. Okay, 15 meters west. Done. 8 meters north. This is 8 meters north. That is E. After we do this, the next step is to create a table. write the vector names here: A, B, C, D, E. Write the name of the vectors there. And this is our horizontal component. And this is our vertical component. So we are going to split each vector into how much is it horizontally, how much is it vertically. Do you get it? Let's look at the first one. Look at vector A. How much of A is horizontal? All 10. How much of A is vertical? 0. It's not at all vertical. It's purely horizontal. Which means that 10 meters along towards the east has two components. One is 10 and 0. There's nothing vertical. Okay? Let's go to B. Let's go to B. That's 20 meters. We need to split it into two components. And which components are we talking about? To go here, we can go like this and then like this. So those are the two components. These are the two components we are trying to find out. Okay? These are the two components we are trying to find out. Now tell me this. Is this the adjacent component of B or the opposite component of B for this angle? So when it is adjacent component, what do? The vector times sine or cosine? Cosine. So what is 20 cosine 30? That's this one. How much is it? What is 20 cosine 30? You know why I'm using cosine here? Because I need this component, which is my horizontal component. And the horizontal component is the adjacent component of this vector. You see it? And now, if you're looking for adjacent component, it is cosine component. So 20 cosine 30, what is it?
17.
How much? 17.32 now. Which way? Is it in the positive direction or the negative direction? So you put negative. Negative 17.32. Now how much of this is vertical? Is here. Is that the opposite component or the adjacent component? Which is sine. So what is 20 sine 30? Positive, negative? Positive is going up. So positive 10. Now, let me remind you right there at that point. If at all someone is going wrong, it is right there. Forgetting to put the minus sign when it's going back. Okay. Let's go to the third vector. 30 meters, 40 degrees just out. So here is 30 meters. We need the two components. Where are the two components for this? One is this, and the other is this. So we want this component, which is the horizontal component. What is that? Is it opposite or adjacent of this vector? Adjacent. Okay. So 30 cosine 40. How much is it? 20?
22.9.
Positive, negative? So 22.9 positive. What is this component? It will be the sine component because you're looking for the opposite one. So what is 30 sine 40? 30 sine 40.
19.3.
Positive, negative? Negative because it's going down. Okay? So negative, what did you say, 19.3? Now go to the next one. D, 15 meters. D, 15 meters west. So what is the horizontal component? Negative 15. What is the vertical component? 0. The last one, 8 meters north. What is the what is the horizontal component? And vertical component? Now you're going to add them up. What is A plus B plus C plus D plus E? What is vector A plus vector B plus vector C plus vector D plus vector E? It's supposed to give you what? R, which is our resultant. Supposed to give you R. Just add these up. 10 minus 17.32 plus 22.9 minus 15 plus 0. What is it? That's decimals, is it? How much? 0.6? Zero 0.6. Is that perfectly 6? 0.58. Go ahead with this one. 10 minus 19, and then this. How much? Negative 1.3. Exactly?
Yes.
Okay. Negative 1.3. So we have now got the resultant, not fully, but in two components. What do you do next? Is a geometric drawing. We're going to do a geometric drawing. Here it is. That is our north, that is south, east, west. On that new diagram, instead of drawing all these different ones, you're only drawing these two. How much is it in the x direction? Only 0.58. How much is in the y direction? Negative 1.3. That means imagine you're walking from here to here, 0.58, and then if somebody's telling you go negative 1.3, which way you go? You don't have to put negative sign there, you already pointed it down. So there's no need to put a negative sign again. Now, what's your resultant? Where is the resultant? That is your resultant right there. Oops. Okay. So we have the x component is marked over here, the y component goes down 1.3, and that is your resultant. How do you find the resultant? Pythagorean theorem. Go ahead. So r is equal to square root of 0.58 square plus 1.3 square, and the answer is how much? 1.42 meters. Is that the end of the story? What do you need to find out? Angle. So find the angle. Find that angle. How do you find the angle? Trigonometry connection. This is opposite, this is adjacent. So tan of the angle is 1.3 over 0.58. What is the angle then? You see why it's 1.3 over 0.58? Because the opposite. Now remember, I'm not going to include minus signs in my calculation because you want this angle and you need the sides. That's it. The minus sign was there only to let you know that it is going down. What's the answer coming out? What is the angle? 66 degrees. Now, which way? South of east. All right. How did this go? You did 5 vectors at the same time. 5 vectors, you're finding the resultant of all 5 vectors same time. Okay? What is going to be the difference if I give you 10 vectors? You'll have more of this, that's it. The process is going to be the same thing, right? The process is going to be the same thing. So if I give you 10 vectors and ask you to find the resultant, you can this will go on That's it. The process is exactly the same. In the end, you'll get two vectors and you find the result. How many of you are okay with it? Good. I'm going to give you a problem and you work it out. Okay? Yeah.
I did the tan is equivalent to 1.3 over 25A, and that got me like 0.039. What else do I do there?
No. What
Oh,
do
the
you,
inverse. Okay, so
how do you get 0.03?
you did.
No. 1.3 or 0.58 is going to be definitely a bigger number. 2 point something. Oh yeah, use parentheses. Very important. All right, go ahead. I'm giving another one and see how it goes. All right, let's say you got 20 meters east, 30 meters at 60 degrees west of north. So 40 meters at 20 degrees east of south and 10 meters west. Go ahead and find the resultant of all these. Find the resultant of 20 meters east, 30 meters at 60 degrees west of north, 40 meters at 20 degrees east of south, 10 meters west. Proceed exactly the same way as I told you. First make a big diagram where you put all those things in, then make the table, and then go for the last one. Sometimes the angles and all that will be given not with respect to north, south, east, west. You may be given horizontal, vertical, or you may be given some other references. Doesn't matter. Still you do the same thing. So the answer looks like it is 22.7. The answer is 22.7 meters at what angle? 84 point south of. I'm not sure of this answer, but looks like many of you got this answer, so that should be right. Because everyone going wrong in the same place, less likely. So that should be the answer.